Now we're going to spend some more time looking at our quadratic formula again as a quick review. And I mentioned before that the quadratic formula actually is derived by completing the square on the standard form of a quadratic equation, ax squared plus bx plus c equals 0. So what we're going to do is we're going to actually spend some time and we're going to derive that now. So we'll follow the same process as we did before. We want to move our constant term over, which in this case is c. We have ax squared plus bx plus our box equals negative c plus our box. Next step is we factor out our leading coefficient of a. So we have a, then we have x squared plus b divided by a, x, plus our box equals negative c plus a times our box. Now, b over 2 squared, our b value is b over a divided by 2 squared. So we're going to have b over 2a squared, which means in our box we're going to end up putting b squared over 4a squared. b squared over 4a squared. Now we can go ahead and factor x plus b over 2a squared equals negative c plus, if we multiply a by this fraction, it eliminates the squared with the a. So we're left with b squared over 4a. Now, what we can do is we'll get a common denominator and we'll go ahead and add these terms together. So in order to get our common denominator here, we need to multiply the top and bottom of c by 4a. So we're going to end up with a x plus b over 2a squared equals negative c 4a over 4a plus b squared over 4a. And with that common denominator, let's go ahead and put the subtraction at the end. B squared minus 4 times a times c all over 4a. Now, we can go ahead and we'll try and take the square root property. So we need to divide both sides by a. Divide by a, divide by a. X plus b over 2a squared equals b squared minus 4ac over 4a squared. Square root property, so we square root both sides. X plus b over 2a equals positive or negative b squared minus 4ac. Can't square root that, but we can square root 4a squared as 2a. And then last but not least, we subtract b divided by 2a from both sides, so that we end up with our familiar formula, x equals negative b plus or minus the square root of b squared minus 4ac all over the common denominator of 2a. Now that we have our quadratic formula, we can go ahead and use it to solve each equation. We'll also go ahead and identify the solutions as either rational, irrational, or non-real complex numbers. So we have our value of a, b, and c as long as our equation's in standard form. A equals 6, b equals negative 5, c equals negative 4. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This simplifies to be 5 plus or minus the square root of 121 over 12, which is 5 plus or minus 11 over 12, which gives us two rational solutions, 4/3 and negative 1/2. And again, we get two rational solutions. Here we need to get it in standard form. So we need to subtract 8x and add 1. So a is 4, b is -8, and c is 1. We have negative b plus and minus the square root of b squared minus 4ac all over 2a, which simplifies to 8 plus and minus the square root of 48 over 8. The square root of 48 reduces to 4 square root of 3. And then we can simplify the fraction, divide all three of these by 4, 2 plus or minus root 3 over 2, which is irrational solution. 2 irrational. Last but not least, we need to expand this out. 9x squared minus 6x 3 equals -8. In standard form, we get 9x squared minus 6x plus 5. A is 9, b is -6, and c is 5. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. 6 plus or minus the square root of -144 over 18 equals 6 plus or minus 12i over 18. We can simplify that as 1 plus or minus 2i over 3. And then we need to write it in the form a plus bi, which means we need two separate fractions. 1 plus or minus 2/3 I, which is a two non-real complex solutions.